Okay, so I made a mistake last time, and I need to redo the disk back queue in the whole queue system. So before, I was thinking that I could get away with having just a queue with a value and without a dat, and it turned out that I can, but I have to create a new method in the queueImpl. So we have the queueImpl here, and it has add and remove. And so I'm going to create a new method, a new function, update, and it will return. It will take a tvar of the queueImpl itself and return a stm of an IO of nothing. And an STM, and I don't think I have the time to explain exactly what it is. It's called. It stands for Software Transactional Memory, but it allows you to basically take any tvar or any sets of tvars and update them all as if in an atomic action. So the point is, how this is going to work is that the whole idea, actually, to back up a bit, the whole idea is that when we create a queueImpl, we use a closure. So we have the queueImpl, and we create it with the functions in here, like for the add and the remove and the update, and they share. They're inside of a function of above, like we'll call it new QI or whatever, and inside in this function it can take parameters such as the list of values, maybe a size counter or something or whatever, and then it returns a queueImpl. And so these functions here can access these variables up here, and that is called a closure. So what they do typically is, like, add will use those variables, would have like the list of items. I didn't really name them up here, but running out of room, but I'll name them. Like this is we called like VL, and yeah, that's a size counter. Actually, that should be an int. It's a size counter. So it could take VL, and then it could, if you want to add an item X, then it returns a new queueImpl. It simply just recalls this function. So it recalls new QI with X colon VL. Actually, let me expand this. And that will, restart or reset up all these functions as new functions with the new variables, and that's how it stays immutable. Now, update, what it will do is it will, like I said, it takes a tvar of the queueImpl and returns an stm of an IO or whatever. So what this will do is it will use the closure variables because they'll be inside the stm, and therefore the parent stm will have read the tvar, this variable here, to be able to call this update method inside the QI, which means, this is getting complicated, I know, which means that that these variables are part of the atomic action, so they can read these atomically. So it can read the length and so forth, and so this way the disk back queue can take a look at the variable length and or the size counter and say, oh, okay, the size is greater than X, so that way I can perform an offload to disk. So it would, if the size is greater than x, so if the size is greater than x, then it will just return an IO operation to perform the offload to disk. And similarly, similarly, if the size is less than a particular value, and there are items on the disk, then it will pull them off and put them, pull from the disk and put them on the queue. And it can also handle errors and stuff basically the same way. So that's, I didn't have a lot of time to work today, but that's basically what I came up with after a long struggle, trying to understand how to do things in Haskell compared to Java. So that's it. All right.